Today we will be showing some of the capabilities of going from 3-axis to 5-axis with Cimatron and how easy it is for new users to get 5x programming going quickly. My name is Andy Strombeck and I'll be presenting today. If you are programming with 3x pathing in Cimatron, then you're able to program 5-axis as well. Our tilting options make it incredibly simple for you to shorten the time programming and use shorter tooling to increase tool rigidity. This can help with higher feed rates and better finishes. The options we're covering today are auto tilting and convert to 5x. Auto tilting is an option we've had for several versions, but the functions has had improvements with each release of the software. Convert to 5x is a new option in version 14. Both of these options take a 3x path and turn it into a 5x path with very little effort. There are some rules of engagement to using these type of procedures. The procedure being tilted must have a ball cutter. So a surface milling procedure, it has to be a ball, and that is the first requirement. Second is single cutter procedures only, no multi-cutter procedures. So we do allow multi-cutters, different lengths, typically, to go ahead and reach these depths that are longer reaches. But really, you shouldn't need it since the tilting can typically get you to full depth. Now that you have that ability, we can use the shorter tool, we can tilt to reach, and you don't have to do all that figuring. Last thing to keep in mind is no undercutting. We cannot tilt a tilted procedure. This seems obvious, but just clarifying before we get the call it support. And the undercutting is really anything that has a backdraft or undercut is considered true 5-axis, and we have some great options for that. But it is a larger package and it's a whole nother animal. So today we're not going to be covering that, and these procedures don't tackle that. So this is really covering reach issues and lengthening your depths very easily without a lot of work. The first option we will look at is auto tilting. By far the easiest option to pick, and in most situations gives pretty good results. Most use this as a blanket tilting application. What I mean is that we're not spot machining one little area. If you're machining a larger area and want to use the shortest tool possible, this is a great option to do a lot of tilting without a lot of programming. Now that's not to say it doesn't work in a small area. I guess we'd refer to this as the easy button. You check it, pick lots of surfaces, let it do the tilting, and you get a result. So when you're looking for something to start with that does a whole lot of tilting in one procedure to cut the most possible surfaces, this is the one you'd start with. So let's go ahead and look at it in a file. In the first tool path, we have a finished procedure that cannot reach all the way down to start the finishing part. First thing that we need to be aware of is that we need to set the tool path to 5-axis. So when we're designing this, we need to go ahead and double click, get this set to 5-axis, and then you can start actually using the options. Now if we look at Navigator here, and I place my tool, we can see I have to switch to a longer cutter here, but because this is a smaller tool, I don't like hanging it out this far. So this is where auto tilt comes in and gives us some really neat options. Now that 5-axis is enabled in the toolpath, it opens up options inside the procedures and offers additional procedures for use. So let's edit this finished procedure. Notice that this looks just like your normal 3x milling. To show how easy this can be, we'll start by checking the box for auto tilt. right here, and we're going to calculate. Let's go to Navigator here. Notice that the tilting is not only automatic, but I get a really clean path with a shorter tool, and it's done all in one procedure. Now, there are times when the default options will not work or be optimal for the geometry you're cutting. We have that covered as well. So let's edit the procedure and see what we have. Under cutter tilt control, we have some additional options that we can modify. Maximum angle. We can limit how far we want the machine to tilt. If you know 90 degrees is a bad option for your tilting, set it to 50 or whatever is best. This is typically something that would be dependent on your geometry as well. Preferred angle. This is the one that's more important. This is the angle which you would like it to cut at. This is preferred and not a forced angle. If the geometry requires an additional tilt to cut, it will continue to tilt up to the maximum tilt angle. I like to use UCS by NC tool to get an idea of the best angle to use. If we go up to by NC tool, UCS by NC tool, I can select my cutter down here. I can place the tool, and then I can tilt around and find an angle that works best. Then when we're in our procedure, I know 10 degrees cleared, so I'll enter 12. And then typically what I would do is add 10 degrees to whatever that is. I'll make it 22, something like that. Just my preference, I find I have better results this way, but it's completely up to each user. Calculate tilting. There's two options here. For all motions, we'll tilt always, meaning when you're rolling off a surface that doesn't require tilting, it will maintain that tilt and continue on until it finishes cutting. We find users split about 50-50 on this. I like to keep the tilt going so the machine is not changing position all the time, but the best option can change depending on the geometry and the machine. So some use only when necessary, meaning if it does not need to tilt, it will go back to straight vertical alignment with Z. For all motions, it will maintain that tilt. The next option we have is avoid tilting on horizontal planar if not required. So right here, when we check this, all this will do is keep the spindle pointing straight up and down in line with Z. So when it hits the horizontal surface and tilting is not necessary, it will not tilt. It will stay vertical. This is a new option in version 15. Tilting priority. Preferred angle will use the entered value we previously entered above. The problem is that if we are wrong and to cut the part, it has to go from the preferred angle of 12 and then tilt to 20. To actually cut the part, your machine might look like it's kind of wobbling around cutting on the machine. So the options you have available now is stable tilt angle. This will find an angle that is a best fit for all motions and stay as close as possible to the preferred angle as it can. So if the best angle is 13 degrees, let's say, and you entered 7, it's going to go to the 13 degrees and it's going to stay on that while it cuts, and this will smooth out the tilting on the machine. So lots of info on auto tilt here, but really make sure to enter a reasonable tilt angle for the preferred tilt. Check the box to use auto tilt and let the system do the work. It's really that easy. So for our people who are new to the 5X machining, this is really going to be one of the places you start. It's a very fast, quick option, and it lets you continue your 3-axis programming with minimal effort to get 5X results. So let's go ahead and check out the next option we have, which is convert to 5-axis. So let's head over to the next toolpath and check out our next option. We need to just clean up this wall. But we can see without tilt, this tool is not going to reach. And my only option is to go ahead and use auto tilt or to go ahead and lengthen the tool. So what options do we have besides auto tilt? Convert to 5X is a new procedure in version 14. Basically, you program your surfaces to cut 3-axis with finish milling and make sure to ignore the holder and shank. So when I come into here, you'll see that the holder and shank settings are set to ignore. Now what this does, when we run Navigator, we can see that it's going to chop right through there. It's clearly not going to work. And this is where the neat part comes in. Right below this finish procedure, we create a new procedure and we go to main selection, convert to 5X. And you'll see in the sub selection, there is no other option here. It is convert to 5X is what you're looking for. Now, there's several options under here. So under the cutter tilt control, we have auto, which is just like auto tilt. So we're not actually going to cover that in here. We're going to look at some of these other options. We have single direction to guide fixed tilt, to guide auto tilt. Now, we're just going to do a few of these. We don't have time to cover them all. We're going to go ahead and start with single direction. Now what this does, it lets us pick a new UCS orientation, and the UCS that we select for the new direction will be the angle of approach and machining. So in this case, I have another UCS that is already tilted. I don't have to activate it. I just have to have a UCS on the angle of approach that I'd like the machining to take place. So I can go to new direction, model, select this short ball UCS here, save and calculate. Now, the first question we get is, if we're not checking holder and shank, how does it know not to create a collision? Oops, let me go back here. Navigator, select, and we can see now that it has converted that 3-axis toolpath and it is no longer hitting. So what happens here is, in the convert procedure, we have gouge checking turned on. So it does the tilting based on the new direction UCS. And if there is still any remaining collisions or any motions that will not work, it will prevent them. So double safe here, more than okay to use. We use the no checking of the shank and holder to get the path on the surface. Then in convert, we turn the checking back on, and then we assign the way that we want it to approach. So single direction uses a UCS. If you have one, great. If not, it's all right in here. So we can actually go create UCS here. We can even go to machine preview. And for those not using that, this is a really neat option. When you select machine preview, we can go ahead and stuff this right into your machine simulator. We can go ahead and place the tool, and it shows us what it looks like right on the machine. And then I can, once I place the tool, I can slide these bars and I can actually see, oh, you know, that's a problem. And I can roll this right over and say that's where I want it. Come down here and say create UCS and exit. When I do that, it inputs it right into the procedure, save and calculate. So I would probably use this more on really hard to reach areas. And you can see this is a great example of the gouge checking. So when it gets over here closer, the shank is still too close to my surfaces and it prevented the motions. And that's exactly what we want. So you can go right back in. We can select the different UCS, or I can go back into machine preview, make one that way, or we can go into create UCS. And again, I can place the tool, but not in the machine sim. Lean this over, hit go, creates the new UCS, save and calculate. And now I have a path that is gouge checking and that is free and clear of collisions. Now, this is a really nice option, but if you have a lot of fixturing or other surface details or parts that might be in the way, that's where the machine preview is nice because it lets you see what it could bump into. So they all have their place. There's lots of options in there, but we don't have to get too complicated. You can make it easy, or if we need to get into more complicated stuff, it's absolutely available to you. So that is option number 1 with single direction. Something to keep in mind here, when you use a convert procedure, it is going to work with the finish mill that is immediately above it. So it is not like transformation where you select procedures. It will immediately grab what is above it. That is the only way that it works. So let's go ahead to the next option we have inside convert, which is to guide. I'm going to turn some of these UCSs off. Let's go ahead and straighten this out. All right. So this is a lot harder to reach, and it's going to be a little trickier to get through here. So I'm going to turn on a guide curve. This is just a line. There's nothing more to it. It's just a line I made up where the UCS exists. So when we look at this, oops. So when we look at this, it is going to be, again, finish milling, ignore the holder and shank. It's going right through the wall. It's got to squeeze into the center area without hitting the other side when it tilts. So what we're going to do now is we're going to go ahead and create our convert to 5-axis. This time instead of single direction, we're going to say to guide. Now, once we select this option, we have min, max angle. So for here, I'm going to put a minimum angle of 0, max of 50. There's no way 70 is needed. Additional tilt. 5. Oh, sorry. 5. Now when we go down to geometry, which was not here before, we have two options, guide contours and guide points. We're going to go to guide contours. We're going to select this line and say OK. And we're going to save and calculate. Now, when we get this tool in here, we can see it squeezed down in there. But what's happening is when it gets closer to the edges, my shank is getting close. So again, this is protecting me when I get into these areas. So my guide curve in this case maybe isn't the best option, but what it's doing, if we watch this, is we go up and down the wall here, it is taking the tool and putting the axis of the tool right through that guide curve. So as we work it down the wall, you'll see the angle is actually changing because it's being pushed through that guide curve. So a neat function and something that can be really useful. But this leads us into our next option here. Let's go ahead and switch this from guide contours to guide point. So now instead of picking the guide curve, I'm just going to pick this point up here, the midpoint of that line. Say OK. And now we get a little better result, right? So as I actually take this and place this, we're going to look down from the top so we can see what this does. Because I picked by point instead of guide curve, it is pushing the tool axis through that point to do all the machining. So it's another way of controlling how it tilts. So it's going to be pushing the spindle axis through that point. And then if we looked at it from the side here, the tilt angle is getting greater. So as we go down, it's getting steeper and it's going to push that shank real close to here. So it's, again, pushing the limits of its comfort for safety. But it gives you an idea of how this works. Now, we do have even more options and we can get as involved as we want, but we can only cover so much today. So you have options inside here, access to guide. Off guide will flip the direction. It will make an opposing, a mirrored result of your tilt. The other thing that we have is when you look in here, we have to guide fixed tilt. And it's a lot like just guide, except we can set an angle as well. And to guide auto tilt. And what this does, let's say something doesn't reach well. So let's go back to here and we're going to unselect this point. We're going to select this line again. Get back, select the guide contour, say OK. But then we're going to use to guide auto tilt. And we know that this was hitting before. So let's see if this gives us a little better result. So what it does, before, the angle that I had determined by using this guide was preventing motions over in these corners. But since I gave it the option to use auto tilt, it actually is adjusting the angle because I was wrong. So the system went ahead and used auto tilt in conjunction with the guide to give me the most machining with the best tilting with the least amount of effort. So these are some really neat options. We don't have to dive too far into picking these because really auto tilt will do a lot and these will do anything it can. And you can really, really make some nice results with minimal efforts. And we're not diving into our 5-axis full package to do this. Anybody that's a 3X programmer can do this. So some really, really neat options. And something that if you're having any trouble with or you want to check it out, reach out to sales and support here and we can help you out. That concludes our webinar for today. If you have questions, please reach out to us at support. Really appreciate everyone's time today. Thanks for coming and have a great rest of the week. Thanks.